A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Your AI just generated 10,000 customer support responses. How do you know if even 1% of them are absolute garbage before they hit a customer's inbox? Honestly, that is the nightmare keeping developers awake in 2026. You build a beautiful pipeline, the demo looks incredible, and then you realize you have no idea if it scales without hallucinating something legally actionable.
It is the gap between a prototype and a product. We have moved past the era of vibes-based development where you just refresh the prompt 10 times and say, looks good to me. Today's prompt from Daniel is about exactly that, the emerging toolkit for automated quality evaluation. How do we actually build a manufacturing line for intelligence that has a quality control department that does not sleep?
I love that Daniel brought this up because it is the most unsexy but critical part of the stack. By the way, quick shout out to Google Gemini 3 Flash for powering our script today. It is helping us navigate this world of evaluators and heuristics. Herman Poppelbarrett, you have been digging into the research on this. Why is traditional software testing just failing us here? I mean, we have unit tests for a reason, right?
Traditional unit tests are deterministic. You input X, you expect Y. If Y is not exactly what you coded, the test fails. But LLMs are probabilistic. You ask for a summary of a loan document, and there are 1,000 ways to write a good summary and 10,000 ways to write a bad one. You cannot write a regex for, is this summary helpful and accurate, but not too wordy?
Right, because the moment you try to pin down helpful, the AI finds a new way to be weird. It's like trying to use a ruler to measure the quality of a poem. You can count the lines, but you can't measure the soul.
If you use a traditional exact match test, you'll get a 99% failure rate even if the answers are brilliant, just because a comma moved or the AI used the word utilize instead of use. We need tests that understand intent, not just syntax.
So we are moving toward this three-pillar approach: LLM-as-judge, heuristic checks, and randomized spot checking. Let us start with the one that feels the most like science fiction, using an AI to grade another AI. LLM-as-judge. It feels a bit like the fox guarding the henhouse, does it not?
It can be if you do not set it up correctly. The core idea is that you take a high reasoning model, something like GPT-4o or Claude 3.5 Sonnet, and you give it a very specific rubric to evaluate the output of a smaller, faster, or more specialized model. Maybe you are using a fine-tuned Llama 3 for your actual production traffic because it is cheap and fast, but you use the heavy hitters to grade its homework.
So it is like having a graduate student grade the freshman essays. But what are we actually asking the judge to look for? Is it just, give this a thumbs up?
Ideally, no. The best practice in 2026 has shifted away from those vague 1 to 10 scales. If you ask a model to rate coherence on a scale of 1 to 10, a 7 for one model is a 5 for another. It is too subjective. Instead, the industry is moving toward binary rubrics or comparative ranking. You ask the judge, does this summary include the interest rate mentioned in the source text? Yes or no. Or you show it two versions and ask, which of these is more concise while maintaining all factual points?
But wait, if we're using a smarter model to judge a dumber one, doesn't that get incredibly expensive? If I'm running 1,000,000 inferences on a cheap model, I can't afford 1,000,000 inferences on a top-tier model just to check the work. That defeats the whole purpose of using the cheap model in the first place, right?
That is the big practical hurdle. In practice, you don't judge every single interaction in real time with the expensive model, at least not in production. You use the expensive judge during the eval phase when you're testing a new prompt version against your test set of, say, 1,000 examples. Once you're live, you might only send a 5% sample to the expensive judge to monitor for drift. It's about statistical confidence, not checking every single homework assignment.
And I saw in the research that chain of thought is huge here. You do not just want the score, you want the judge to show its work.
That is crucial for debugging. If the judge model says a response is a fail, but the explanation shows the judge actually misunderstood the prompt, you know your evaluation layer is the problem, not your production model. It provides an audit trail. But we have to talk about the biases, because these judge models are not perfect. They have some really specific quirks that can ruin your metrics if you are not careful.
Like what? I assume they have a bit of a teacher's pet energy where they like models that sound like them.
That is exactly one of them, self-preference bias. Models often favor outputs that mirror their own training style or architectural quirks. If you use a model from the same family to judge its sibling, it might overlook errors because the phrasing feels natural to it. But the two biggest ones people run into are position bias and verbosity bias.
Verbosity bias, I can guess. It is the more is better trap, right? If the AI writes a 5-paragraph essay that says nothing, the judge thinks, wow, look at all that effort, 10 out of 10.
Precisely. In side-by-side tests, judge models consistently rate longer responses higher, even if they contain what we call filler or fluff. It confuses length with quality. It's the AI version of a student who writes 3 pages for a 1-page assignment, hoping the teacher won't notice they didn't actually answer the question.
And position bias is even weirder. If you ask a judge to compare 2 outputs, it is statistically more likely to pick the first one you show it, just because it saw it first.
It's true. It's a documented phenomenon called primacy bias. If you present answer A and then answer B, the model is predisposed to favor A. If you flip them, it might favor B. It's almost like the model gets tired or settles on the first plausible answer it sees.
That is hilarious. The most advanced intelligence we have ever built has the attention span of a toddler who just wants to finish their chores. So how do you fix that? Do you just swap the order and ask again?
That is actually a common technique. You run the evaluation twice, swapping the positions of the candidate responses, and if the judge flips its answer, you throw out the result as inconsistent. There was a case study from a fintech startup recently. They were using GPT-4o to evaluate loan application summaries. They realized the judge was penalizing their production model for being too concise. They had to explicitly add, brevity is a virtue, and conciseness is mandatory to the rubric to stop the judge from rewarding word salad.
It is like we are back to prompt engineering, but now we are prompt engineering the police. Which models are actually winning the Best Judge Award lately? I know you mentioned a model called Prometheus 2.
Prometheus 2 is fascinating because it is specifically fine-tuned to be an evaluator. While GPT-4o and Claude are generalists, Prometheus is trained on evaluation datasets to follow rubrics more strictly and avoid that verbosity trap. It's an open source model, which is great because you can host it yourself and run your evals without sending all your data back to a big provider.
So if I'm building a pipeline, I might have Llama 3 for the customer, Prometheus 2 for the grading, and then maybe a human checking Prometheus once a week.
That's the dream architecture. But for most teams, the gold standard is still just using a model that is at least 1 tier smarter than your production model. If you are shipping with a 7 billion parameter model, judge it with a 100 billion plus parameter model.
Okay, so LLM-as-judge is the sophisticated, slightly biased professor. But before we even get to the professor, we need the metal detector at the door. That is where these heuristic checks come in. These feel much more traditional software engineering, right?
They are the deterministic safety nets. Think of them as the dumb tests that catch the dumb mistakes so you don't waste money and latency on an LLM judge. If your AI is supposed to output JSON for a database and the output is just a paragraph of text, you do not need a multi-billion-dollar model to tell you it failed. A simple format check catches that instantly.
I love the verbal tick detection. Is that literally just looking for phrases like, as an AI language model, or I am sorry, but as a large language model created by...
Those are signs of a model refusal or a collapse, where the model is falling back on its safety training instead of answering the prompt. If you see those strings, you can automatically flag that as a failure. It's the most frustrating thing for a user asking for a recipe and getting a lecture on the ethics of kitchen safety.
You can also use regex patterns for things like PII, personally identifiable information. If your customer support bot suddenly spits out a social security number or a credit card format, the heuristic check kills the process before it ever reaches the user. I assume that's a non-negotiable for anyone in enterprise.
You don't need an LLM to tell you that a 9-digit number in a specific format looks like a social security number. You just block it. Another one is hallucination markers for specific domains. Like, if you're a travel site and the AI mentions a flight to a city that doesn't have an airport, you can have a simple lookup table that flags that as a likely hallucination.
What about length validation? It sounds simple, but I imagine it is actually quite effective for catching hallucinations. If I ask for a 50-word summary and I get 300 words, something has gone off the rails.
It is a great proxy for model drift. Another cool one is semantic similarity using embeddings. You take the vector of the source document and the vector of the generated summary, and if the distance between them is too large, it means the AI has wandered off into a different topic entirely. It is a mathematical way to detect a hallucination without needing to read the text in the traditional sense.
Wait, can you explain that embedding check a bit more? How do you know what the correct distance is? Is there a standard number?
It's usually a cosine similarity score. If the score is, say, 0.95, they are very close. If it drops below zero point 0.7, the AI is likely talking about something else. You establish the baseline by running it on your golden data set first. If your known good summaries usually have a similarity score of 0.85, then anything that hits 0.6 in production should trigger an alarm. It's like a smoke detector. It doesn't tell you where the fire is, but it tells you something is burning.
It is amazing how much you can catch with just these basic filters. It is like having a "you must be this tall to ride" sign before you let the AI talk to the public. But then you have the third pillar, randomized spot checking. This sounds like the human in the loop part that everyone says we need, but nobody actually wants to do because humans are slow and expensive.
It is the guarding the guards phase. You cannot automate everything. Even your LLM-as-judge can drift over time as the underlying models are updated by OpenAI or Anthropic. Teams in 2026 are typically sampling between 1 and 5% of their total traffic for human review, but the key is stratified sampling.
Stratified. Explain that for the non-data scientists in the back.
Instead of just picking random samples, you focus your human reviewers on the gray zones. If your automated judge gave a response of 3 out of 5, or if it was a pass, but only by a narrow margin, those are the ones you send to a human. You do not need a human to check the ones that passed with flying colors or the ones that failed the regex check. You use humans to refine the rubrics for the AI judges.
It's essentially active learning for your evaluation pipeline. You're using humans to solve the edge cases that the AI judge struggled with. Does this ever lead to disagreements where the human says, "This is great," but the AI judge said, "This is terrible"?
All the time. And those disagreements are the most valuable data points you have. It usually means your rubric is ambiguous. If the human likes the response because it was friendly, but the AI judge hated it because it wasn't strictly professional, you have a decision to make about your brand voice. You then update the prompt for the AI judge to reflect that friendly is okay.
So the humans are basically teaching the AI judge how to be a better judge. It is a recursive loop of quality. Now, Daniel mentioned some specific tools here: LangFuse, BrainTrust, Human Loop. I feel like every time I look at a tech blog, there's a new evil ops platform. What are these actually doing? Are they just fancy databases for logs?
They have evolved a lot. A year or two ago, they were basically just logging wrappers. Now, they are full-blown evaluation hubs. Take LangFuse, for example. It is open source and focuses heavily on observability and tracing. It lets you see the entire trace of a request, from the initial prompt to the vector database retrieval to the final LLM call, and then it attaches the scores from your judges and heuristics to that specific trace.
So, if a customer complains about a weird answer, you can look it up in LangFuse and see exactly which step of the pipeline failed.
Precisely. You can see if the retrieval step fetched the wrong documents or if the model just ignored the documents it was given. Brain trust takes a slightly different angle. They focus on the prompt playground and iterative development. It is built for teams that want to test 50 different versions of a prompt against a golden dataset of known good answers and see a leaderboard of which prompt performs best across all your metrics. It turns prompt engineering into a data science experiment rather than a guessing game.
I've seen those leaderboards. It's like a sports bracket for prompts. Prompt A beats Prompt B on accuracy, but Prompt B is 20% faster. How do people actually choose which one to ship?
It's always a trade-off. Brain trust lets you visualize those trade-offs. You might decide that for a medical app, you'll trade any amount of latency for a 1% gain in accuracy. But for a creative writing bot, you might prioritize speed and vibrancy scores. These platforms give you the hard data to make those business decisions rather than just going with your gut.
And Human Loop? I am guessing the name gives it away?
They are the leaders in that human-in-the-loop workflow. They make it really easy to set up internal tools where your domain experts, maybe your lawyers or your senior support staff, can quickly rate outputs, and then that data is fed back into the system to fine-tune your judge models. It is about creating an audit trail for regulated industries. If you are in healthcare or finance, you cannot just say, the AI said it was fine. You need a record of who reviewed what.
I am curious about the Shadow Evils trend Daniel mentioned. That sounds like a genius way to test new versions. You basically let the new AI ghost. The live one?
It is identical to dark launching in traditional DevOps. You have your live production prompt, version 1.0. You want to deploy version 2.0. Instead of just switching it over, you run version 2 in the background on every real production request. The user never sees it, but your evaluation pipeline scores it in real time. After a week, you have 1,000 data points showing exactly how version 2 compares to version 1 on real-world data, not just your test set.
That sounds like it would catch those black swan events. The weird edge case queries that you never thought to put in your test set, but that real users ask all the time.
No matter how good your golden data set is, users will always find a way to be weirder than your imagination. Shadow evals let you see how your new prompt handles the chaos of the real world before it has the power to do any damage.
That takes so much of the anxiety out of hitting deploy. You already know if it is going to break things. But here is the million-dollar question. When do you actually block a response versus just flagging it? I imagine you do not want your app to just hang for 10 seconds while it decides if a sentence is polite enough.
That is the bottleneck problem. You have to categorize your evaluations into gates and audits. A gate is a high confidence check that happens before the user sees the output. Things like PII detection, toxic content, or invalid JSON. If it fails a gate, you block it immediately and either retry the prompt or return a graceful error. These have to be fast, usually heuristics or very small fast models.
And the audits are the post-game analysis.
Audits are for the subjective stuff: tone, helpfulness, style. You let the response go through to the user so you don't kill the latency, but you log the score. If you see your helpfulness score trending down over 1,000 requests, you know you have a systemic problem to fix in the next sprint. It is about balancing safety with user experience.
It is like the difference between a bouncer at a club who stops people at the door and a security camera that just records what happens inside. You need both, but you do not want the bouncer asking every person for their life story before they walk in.
That is a great way to put it. To take the analogy further, the bouncer is your heuristic check, fast, looking for obvious trouble. The security camera is your LLM-as-judge, reviewing the footage later to see if things are generally staying orderly. And to avoid the bottleneck, you have to build these evals into your CI/CD pipeline. It should be just like running your test before a pull request is merged. If your new prompt drops the accuracy score on your golden dataset by more than 2%, the build should fail automatically. It forces the developers to treat AI quality as a first-class citizen.
I can imagine a developer getting a build failed notification because their AI became 3% more sassy than the brand guidelines allow. That's a very 2026 problem to have.
It really is. But it's better than getting a lawsuit filed notification because your sassy AI gave a customer bad financial advice.
So, if I'm a developer listening to this and I'm currently just vibing my way through my AI app, where do I start? What is the step 1 for building a real evaluation stack?
Step 1 is always the dumb heuristics. They are cheap, they are fast, and they catch the most embarrassing errors. Set up some basic checks for length, formatting, and forbidden phrases. Then pick a golden data set, maybe 50 examples of perfect inputs and outputs that you know are correct. This is your North Star.
50 sounds manageable. I think people get overwhelmed thinking they need 10,000 examples to start.
Quality over quantity. 50 high-quality pairs are worth more than 10,000 mediocre ones. Once you have that, you can run your prompt against those 50 examples every time you make a change. Then, and only then, you start playing with the LLM-as-judge once you have those basics down.
And then you start exploring platforms like Langfuse or Braintrust to automate the whole flow. But do not jump to the fancy tools until you manually understand what good looks like for your specific use case.
If you don't know what good is, no tool can find it for you. You have to be the one to set the standard.
I think that is the biggest takeaway. You cannot automate the definition of good. You have to define it first, then train the machines to recognize it. It is fascinating to see this whole new layer of the software stack being built in real time. It is not just about the model anymore. It is about the system around the model.
It is the industrialization of AI. We are moving from the blacksmith era, where every prompt is a custom piece of art, to the factory era, where we have repeatable, measurable quality. It is the only way we are going to reach a point where we truly trust these systems with high-stakes tasks. We are building the metrology of the mind.
Well, I feel a lot better about our robot-generated future now that I know someone is checking their homework. Or at least, another robot is checking their homework.
And we are checking the robot that checks the homework. It is turtles all the way down, corn.
Cheeky, but true. I think we have covered a lot of ground here, from the biases of judge models to the deterministic safety nets of heuristics. It is clear that evaluation is not just a nice-to-have anymore. It is the fundamental requirement for shipping anything meaningful in 2026.
It really is. And as these agents start doing more than just chatting, when they start moving money and making decisions, the stakes of these evaluation gates are only going to go up. We are moving toward agent-as-judge, where the evaluator can actually use tools to verify facts. Imagine a judge that can look up a real-time stock price to see if the production model's answer was factually correct.
Now that is a level of accountability I can get behind. A judge that doesn't just think, but actually checks. Well, I think that is a wrap on this one. Thanks as always to our producer Hilbert Flumentop for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power the generation of this show. Their serverless infrastructure is actually a great example of the kind of reliability people are looking for in these pipelines. You need that rock-solid foundation if you're going to run thousands of evaluations a day.
This has been my weird prompts. If you are finding these deep dives helpful, do us a favor and leave a review on your favorite podcast app. It really does help other people find the show. It's our own little human-in-the-loop evaluation for this podcast.
You can find all our episodes and the RSS feed at myweirdprompts.com. We've got some great deep dives coming up on vector database optimization and the future of multimodal agents.
See you in the next one.
Take care.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth for man, from long-eared host. My Weird Prompts, until next time, stay curious, keep weird in mind.